Thank you, Alper. It was a great talk. So, anyways, to our next speaker, who played the challenge, the underground challenge over here? Who had problems, for example, with the Stegano, and it was very hard? So we need to thank Guy. Guy, you are the next one.
Oh, scary. Ugh. I should say Mufasa. Okay, so related to Chris Nickerson's talk, what I want to show you in these slides and this topic is that sharing of information is important. And it's really important considering the length of time that the cybersecurity, even before cyber was named cyber, accumulated knowledge and shared between the participants. So, wrong button. First of all, legal disclaimer, ignore it. Who am I? No, I'm required to show this by my employer. My name is Guy. I worked at a couple of startups, a couple of corporates, currently working at Intel at the Security Threat Analysis and Reverse Engineering team. A mouthful. We call ourselves ISTER. My first computer, Commodore 128D, the one with the Sprite edition. Nobody remembers what it is except the very old folks here. And I'm a Linux person. I absolutely know nothing about Windows. The last time I even programmed an application for Windows was Windows 95, somewhere around 97, 98, more or less. So I want to discuss some old concepts. And when I say old, I don't mean like old, let's discuss the primeval ooze of history. I mean like old when new guys don't really understand that these are old concepts. Like, how was ASCII built? What we can use ASCII for? What is even ASCII now? Everybody knows UTF-8, but how does ASCII tie into it? Low bandwidth application. Who really even cares about low bandwidth in today's world? We all have ADSL and VDSL lines and high speed and fiber optics. Space efficiency. Who really cares about space efficiency? Who cares if my payload is 12 bytes or 16 bytes? We have loads of storage, terabytes of information, petabytes of storage. All of these are very, very important topics, and I'll try to convince you why that is. Just to give you like small tidbits of where I'm trying to go with. Let's imagine an application, a really cool application, something everybody can use. It has text-based chat. It has specific channels. It has private channels if you just want to discuss something privately with 1 or 2 or 3 people. It even can give you the ability to share files or even share images or GIFs or all kinds of nifty topics. Most of you probably think I'm talking about Slack. I hope most of you will think I'm talking about Slack, but I'm not. I'm talking about IRC. So for the young folks who actually don't know what I'm talking about, IRC, or Internet Relay Chat, was the kind of thing that we had, I don't know, 15 years ago, 20 years ago, when it was mostly popular. It went away kind of. It kind of came back with Slack, bigger, better, improved, not innovative in any way. So whenever I see Slack, and I really love Slack, I use it all the time, it's not new. You can convince me that it's new. It's a great tool, though. So a couple of words about where this technology kind of came from. We all seen pictures of, yeah, we have a typewriter, we have Morse code, then we have teleprompters and everything else. But what I find interesting is the underlying concepts in technology and the way that we're still seeing some of them today. For example, this teleprompter or teletype is the reason that we are still seeing /dev/TTY, which I hope most of you are at least familiar with. So that's the reason we're still seeing these. And these kind of remnants are still around us in many occasions. For example, when we're talking about screens, did anybody ever wonder why we have 80-character width limit and a 25-character or 50-character height limit on text? There's absolutely no reason, obviously, in today's world. But in the olden days, there used to be. That was the size of the screen. That was the size of the output you can output and push into the screen memory. That was the way that the memory buffers were arranged. And we're still seeing remnants of this today. We're still using the same kind of formats, the same kind of default configurations for our terminals, but there's absolutely no reason for it. But at least we'll know where it came from. A lot of the, yeah, raise your hands if you actually know what this is. Yeah, about 50%. Okay. Not known, heard one. Heard one. This is the thing that went whenever you wanted to have some internets.
Cyber!
Yeah, exactly. So whenever I'm thinking about bandwidth and modems, this is the kind of thing I'm thinking about. This is a 2400 baud modem. This kind of thing transmitted like characters per second. 100 characters per second. So we're not talking about megabytes of transmission per second. We're talking like literally bytes per second. And you say, oh, how is this relevant to today's world? And the reason that I'm showing this right now, and I will show it again in a couple of slides, is that I had in my own personal experience, we were trying to convince a Wi-Fi module on one of our SOCs, system on chips. We were trying to change the MAC address, the default MAC address that the wireless Broadcom model had on that SOC. And the only way to communicate, the only stack available to communicate with that Wi-Fi thing was 80 commands. Again, who remembered what 80 commands are? Again, 40%, maybe 30%. 80 commands used to be the way that you would talk to modems. They only understood 80 commands. You would say ATH, ATC, all kinds of commands to ATDT, yeah, Z modem. And that was the way that you would communicate with modem and tell them, okay, I want you to open a dialing connection to this number, or I want you to change the parity, I want you to change the way that you're signaling. And this didn't go away from the world. We're just hiding it like under drivers and the firmwares and stuff. But it's still there. It's still useful. And you should at least be aware that it's there so you'll know what to look up and Google search on or go on Stack Exchange when you're trying to find information. Another core concept that I want to show, which has absolutely no relevance to anything anymore, just I think it's cool. This is something which I really expect most of you not to know what it is. But this is the reason we have cores. When we are saying core, this is the origin of the world. A core is actually a magnetic ferrite core. It's a kind of a torus or a ring where you would thread a couple of threads through it in an orthogonal direction. It's a kind of XY grid. And this is kind of the way it actually looks. And then you will thread another thread diagonally through it, and you will address it by firing up some current to the wires, and you will measure the current on the diagonal wire, and then you will change the magnetic properties of that specific addressed bit. And that's the way bit memories worked once. And this is actually about a cube of about 1,000-bit memory. This is like 1K memory. Before 2000, more or less, when people say we have a core, or our core did something like this or something like that, that's the core memory unit. Not anymore, just cool. Okay, PDP-10. A thing that I find often in conversation, which is pretty funny, that people don't really know that there used to be a world beyond 8-bit and 16-bit and 30-bit computers. There were stuff like 36-bit computers. So, well, yeah, and they work pretty well. And that's we kind of see like remnants from this by the way that we're still using octal representation to do stuff and not only hexadecimal representation to do stuff. And the reason we are still doing octal in many, many ways is because we wanted to address multiples of 8 and not just multiples of 16, just like a tidbit. Another pet peeve for me is serial protocols. I have been working with serial protocols over SCADA and IoT and all kinds of stuff, and nobody really knows what they are. Only old guys who actually did this, and nobody knows like what's an RTS and a request to send and all kinds of wires that are going on inside them. And you will say, well, this is old tech, who cares? And the answer is, well, you should care. That's still a major part of the world. We're all part of what we call the IT realm. Well, there's an even larger, well, maybe 10 times larger world called the OT realm, the operational technology realm. And that's like the way things are done. Maybe not on DB9 interfaces, could be RS-485. But serial protocols are still the way to go. They're more robust. They have less interference from outside environment. They're not very fast, but very reliable. And we can do lots of stuff with them in a simpler way. Think about embedded devices. Simpler way, more reliable for longer periods of time. You have a product shipping out for 20 years. That's the time frame we were thinking of. Screens used to be the way that most of us looked at things, but we kind of forgot about what screens are or what screens were originally for. And I kind of like seen in Facebook games or Facebook apps or whatever it's called now, a resurgence of text-based gaming, like the new best thing, the newest thing around the block is text-based games. And not only that, it's like a flashback into the days of BBSs. Just whoever doesn't know what this means, please raise your hand so I know where I'm looking at. Great. Okay. In days of olden past where dinosaur roams the earth, way back, we didn't have the internets. What we had was a group of people, each of them sharing his own server at home on his phone line, where his sister would get mad of him of hogging up the line, and his mother would still get mad of him of spending so much money on calling other people's computers. And you would share files, and you would share ideas, and you would play games. Cool game. I played it myself. This is like the way games used to look. Colossal Cave Adventure. Who remembers that game? Colossal Cave Adventure? Oh, we have like 3 people. Zork? Anyone? Yeah, Zork. That was the era of games where you actually had to pay attention to the plot. It was not just point and shoot. You had to think, you had to build maps of where you're going and where you've been and who you encountered and what they told you. It was a lot of fun. And just to pick your interest, a couple of things that you can still see remnants lying around today. I talked about the modems. This is the standard ASCII table all the way from 0 to 127, the first half. And if I'll just highlight this, these are all commands which you can still encounter in binary protocols today, doing all kinds of regular ASCII stuff where ASCII was designed to do them. For example, ACK, acknowledge command, or do a, where was it, yeah, signal start of header, end of text, start of text. These are all kinds of opcodes or message headers that you will encounter when looking at binary protocols, especially binary protocols, which are pretty old. And you should at least be aware where it came from or where to look up that information. Well, I kind of rambled on about the past for the past 13 minutes. What about now? So low bandwidth systems is something that we encounter daily. And it seems like who doesn't? That wasn't me. I have no idea where it came from.
It's not me.
The computer had a couple of shots as well. Okay, I get an extra minute now. Low bandwidth. So when I'm thinking about low bandwidth systems and thinking about the way that different communication systems interact, they have different properties than high-speed systems. And the reason that I'm showing a big car on the screen here, you might have heard that Intel paid a couple of dollars to buy an automotive company in the past months. And this is one of the realms that I'm looking at now. It's like autonomous driving and in-vehicle system, in-vehicle networks, etc. And when you're going down to the level of the ECUs, the actual components talking between them on the network inside the car, this is the kind of things that you're looking at. CAN bus, in one of the networks running around in the car, don't use like kilobytes of messages, high bandwidth, high frequency, well, high compared to a PC and the personal computer and the internet. We're talking about low bandwidth. We're talking about short messages. We're talking about repetitive messages and broadcast networks, the kind of things that we are not used to look at when we're looking at networking. So you should be more aware of that these kind of things still exist. Another kind of surprise is that we have these kinds of systems. This is like a very, very common, cutting edge, the newest, bestest, greatest, whatever you can buy, COTS, commercial off the shelf, SCADA component. And if you look carefully in the big green interfaces on the front, that's serial. It's not because it's old. You can buy it right now. It's because the entire system uses serial and you are not going to run away from it. So knowing about serial interfaces, the way the serial networking works, the way that the binary protocols run inside that serial network, is a huge advantage to anyone looking into these kinds of systems in the operational technology realm. Low-level analysis is something that at least, I don't know, 15%, 30% of us do, which is like the basics of reverse engineering, diving into the binary analysis, understanding what the opcode does, even if it's a system that you're not familiar with. This kind of techniques or knowledge will be more and more common as the IoT or big data is going to grow. And the reason that I hypothesize this is that whenever you take lots and lots and lots of small data, you couple it up with many, many, many big devices, each of them running on different platforms, doing different stuff, different protocols with different aims, you will need to dive much deeper into each instance, into each specific product that you're looking at and trying to understand, and there will be less common ground. There will be less common ground, and you will need skills with a Z. You'll need skills to go and find out if what you're looking at is this some kind of binary protocol that I encountered before? Is this something that I can easily reverse? Can I extract this firmware? Does it have any kind of network interface that I can sit on top of? Maybe not a network interface. Does it have a serial interface that I can sniff? All kinds of these questions are very paramount. But more than that, the advancement around big data also promises us that old skills that already passed away from the world will return. And one of them, just a small example, is think about big data. And in big, you want me to kick it? Excellent. Move. No? I move too much. Okay. That's the line. I'm not supposed to cross this line. I'm scared now. Okay. These kinds of skills are going to be needed because when we're talking about big data and we're talking about gigabytes of traffic, terabytes of traffic, petabytes of data stored, this needs to be compact. And the best way to compactize this, to compress this, is to go back to the source and rebuild the data structures in such a way that they would be efficient. So efficiency, and specifically storage space efficiency, is going to play a much larger role in the way that we are looking at things. I want to close up with a couple of slides. And hacking and the idea of what hackers are is not just people in hoodies or iRobot or whatever, Mr. Robot, sorry. Mr. Robot or whatever else is depicted on television, or him. Hacking is a community. Hacking is making stuff, is understanding how stuff works, and more often than not breaking that stuff, paying for a new one, doing it again, and teaching others and sharing with others. And well, maybe my main point, and I'll target him again. Respect your elders. Talk to your elders. And more than that, learn from your elders. Stuff that you're doing now, who's cutting edge, you're at the forefront, the best of the startups, they probably encountered the same kind of shit years ago. They solved that shit, and they probably can offer lots and lots of information of how to do that shit better. Talk to them. Share information. Again, this is a community. We are a community. And from here, before I finish up my slides, I still have a minute, I want to take a challenge to all of you guys. My name is Guy. I'm up here on the stage. Please come talk to me. Talk to each other. Talk to everyone. Again, as Chris said, the point of going to a conference is meeting people, not watching slides. I can send you the slides via email. Won't help you much, but yeah.
Yes.
Share information, share slides, share ideas, share techniques. Just a couple of pointers to anyone who has their phones out. I recommend going through this book. Anyone who didn't read this book yet, read this book. It's maybe one of the best written stories about how a hacker becomes a hacker. This is the book, one of the newest versions of it. Eric Raymond. Find his blog, read all of it. It's a manifest. It's like, I don't know, 200 pages. Read all of it. Super important stuff. And some of the things that I'm talking about here came from his blog, so kudos to him. And self-promotion slides. Like everyone said, we're hiring. That's it. Not going to show it again. My time is up, and I'm stealing a minute. Challenges. I know that a lot of people who actually did the challenges wanted to hear some more information, so I'm going to dedicate 2 slides to understand what the challenges are and what they were. If you didn't have a chance to participate in the challenges, come back next year. Hopefully, there will be more challenges. The idea behind these challenges, we had a couple of different challenges, about 8 different challenges. And the idea behind the challenges, when the group that built this challenge site did this, was to help educate and share information and introduce concepts inside the bigger community of software developers and raise awareness around security. And we tried to do the same thing. And one of the main points behind designing these challenges was not to share answers to specific challenges, but to promote discussion and sharing of techniques and ideas. What you see on the graphs here is the number of people who solved each riddle, and unsurprisingly, they're kind of stacked by order of difficulty, from SQL injection being the easiest and steganography being the hardest. So everyone that was able to solve all of these challenges, 42 people totally, kudos to you. Yeah. Winners will be announced later today, and stick around, our cool prizes. Thank you for everyone for their feedback and their replies and talks about the challenges. That's the software stack I used. Really no reason, I just felt like doing Docker and stuff. And thank you very much.
Guy, thank you.